Hi students, welcome to Roots Academy. Myself, Inayatullah, lecturer of mathematics. Student, in our last video, we discussed the problems of differentiation, and in that we completed the topic called chain rule. So in last video, we discussed the problems related to chain rule. Now students, in today's video, we will discuss the problems based on implicit function and inverse trigonometric functions, which are very important in our second PUC annual examination. So student, let us start the problems of differentiation, and in that implicit functions first. This is the second topic in our second PUC differentiation. Implicit functions. Student, what is exactly implicit function is? Student, so far whatever the functions we discussed, it is in this particular format. Y is equals to f of x, where x is independent and y is dependent. This kind of functions, where x and y are completely separated, these kind of functions are called as explicit functions. Explicit functions. Then what exactly implicit is? Implicit is, if I have a function f of xy is equals to k. F of xy is equals to k. Then these kind of functions are called as implicit functions. Because here x and y, dependent and independent variable, both comes together, comes in one particular place, left hand side, or it is multiplied together like that. So these kind of functions are called as implicit function. For example, if I take the function x square y plus y is equals to e power x, this is implicit function because x and y are together here. Next, another function, another example, sin y plus cos x is equals to e power y. You can take here x also. It means y is not equals to x here. X and y are together. Another example we take, that is y into sin x plus e power y is equals to x into y square. Good. So y is not equals to f of x here. It is x into y is equals to something. So students, these kind of functions we will call it as implicit functions. So now students, let us see how can we differentiate these functions. Because since the first problem based on implicit function is if if 2x plus 3y is equals to sin x, 2x plus 3y is equals to, find dy by dx. If the function is 2x plus 3y is equals to sin x, we should find dy by dx. Solution. Given 2x plus 3y is equals to sin x Let us differentiate y with respect to x. Differentiate y with respect to x. Because here, whether it is implicit function or explicit function, always y is dependent. Y is dependent on x. So x is independent, y is dependent. So while differentiating, we should use differentiation y with respect to x only. So what do we get? Coefficient as it is. Derivative of x with respect to x is 1 plus 3. Derivative of y with respect to x is dy by dx is equals to derivative of sine is cos x. So independent of dy by dx, I will shift it to one side. 3 dy by dx is equals to cos x minus 2. So finally, dy by dx is equals to cos x minus 2 divided by 3. Now let us go to the next problem. If x into y plus y square is equals to tan x plus y, find dy by dx. Find dy by dx. In our function, dependent and independent variable multiplied here. So the moment we said two functions are multiplied under differentiation, we should know that there we should use product rule. Our solution is given x into y plus y square is equals to tan x plus y. Y is dependent here. Differentiate y with respect to x. X is independent variable always, and y is dependent variable. The moment I said differentiate y with respect to x, then here I should use u into v rule. As I said earlier, we should use product rule, or also we can call it as UV rule. What is product rule says that? It says keep the first function as it is, that is x as it is, differentiate the second one, its derivative is dy by dx, plus second function as it is, derivative of x with respect to x is 1, plus derivative of y square is 2y, but since y is dependent, we should separately differentiate y, because in general, what students will do the mistake? Student, in this case, maximum students will commit one mistake, and that is they will consider that it is x square. And we know that derivative of x square is 2x. So based on that, they will write derivative of y square is 2y only. This is a mistake maximum students will do this kind of problems. But student, here, the moment we said derivative of x square is 2x, is because x is independent variable here, so its derivative will be 2x. But in this case, y is dependent, when we consider it is in the form of x square and we wrote 2y, then again we must differentiate y with respect to x. That can be written as dy by dx. So the complete derivative of y square is 2y dy by dx. But in case of x square, we will not do this. because dx by dx is 1. So you will avoid writing 1 here, but here we must write. This is equals to derivative of tan x is secant square x plus derivative of y is dy by dx. So here I have x and dy by dx, and here I have dy by dx. We make dy by dx comes one side, shift, we get minus dy by dx. This is equals to, sorry, one more dy by dx there, plus 2y dy by dx. This is equals to secant square x minus y. This y into 1, which will get to right hand side. So in these three terms, dy by dx is exist. So easily I can take common. Dy by dx, if I move outside the bracket, then the left out part is x minus 1 plus 2y. This is equals to secant square x minus y. So finally, my dy by dx is equals to secant square x minus y whole divided by x minus 1 plus 2y. This is the final answer. Okay, students, now let us go to the next problem. If x square plus x into y plus y square is equals to 100, find dy by dx. Here again, in this function, student, independent and dependent variables are multiplied together. So in this case, we should use product rule. Solution. Given x square plus x into y plus y square is equals to 100. Sorry. Differentiate y with respect to x. First, derivative of x square is 2x plus u into v rule here. So first function as it is, derivative of y is dy by dx plus second as it is, derivative of x is 1 plus derivative of y square. Derivative of y square is 2y into dy by dx. As we discussed in the last problem, derivative of y square is 2y. After 2y, we should differentiate y again with respect to x. This is equals to 0 because it is 100 and it is a constant. And we know derivative of constant is 0. So here 2x plus y, 2x plus y. This is equals to this dy by dx terms. I am shifting to right hand side. If you want, we can shift the independent of dy by dx terms also to the right hand side. No issues. That always we should shift dy by dx terms, or we should shift independent of dy by dx terms. Any particular terms we can shift, but make sure that dy by dx terms are one side and independent of dy by dx on the other side. If I shift the terms, we get negative sign minus x dy by dx minus 2y dy by dx. After that, 2x plus y is equals to minus dy by dx is common here. The left out part is x plus 2y. Finally, our dy by dx will be 2x plus y divided by minus of x plus 2y. This I cross multiply to denominator. Okay, students, now let us go to the next problem. That is, find dy by dx if y plus sin y is equals to cos x. So student, here this y is with trigonometric function. Solution: given y plus sin y is equals to cos x, differentiate y with respect to x, differentiate y with respect to x. Student, derivative of y with respect to x is very simple. It is dy by dx plus, here we should be careful. As I said, y is dependent variable. It is dependent on variable x. So first, I should differentiate sine, and I know that derivative of sine is cos. Y as it is, whatever the angle is exists for function, its derivative also gets same angle. Now, student, after differentiating sine, in this case, I should differentiate y also, because always we know that derivative of sin x is cos x. Here capital D means dy by dx. Derivative of sin x is, we simply write cos x. Again, we will not write dx by dx, because dx by dx both gets cancelled, one we will get. But student, in this case it is y. So we must differentiate y again with respect to x. So we will get dy by dx also here. This is equals to derivative of cos x is minus sin x. So again, here I am not write dx by dx, because we know that it is 1. For your reference, I am writing this 1. Now I have two dy by dx terms. Let me take dy by dx common here. What do we get? We get 1 plus cos y is equals to minus sin x, and at last our dy by dx is minus sin x divided by 1 plus cos y. So here further simplification is possible. It is possible to simplify. We can apply the formula here. It is for 3 marks. Better we apply the formulas also. But if it is for 2 marks, let us stop here. So I will continue here. I will continue. Minus will write as it is. Minus. We know that sin x is 2 sin x by 2 into cos x by 2. It is sin 2x formula applied, and converted multiples to half angles divided by 1 plus cos y. Its formula is 2 cos square x by 2. 2 cos square x by 2. So here 2 gets cancelled. Cos and cos gets cancelled. Then finally we will get it is sin x by 2 divided by cos x by 2. Finally it is tan x by 2. It's the final answer. For your reference, I will write it here that we know that sin 2x can be written as 2 sin x into cos x. Sin 2x formula here is. Now in this I don't want this 2. So wherever I have an angle, there I will divide by 2. So what is my sin x? My sin x is 2 sin x by 2 into cos x by 2. This is the formula I wrote it here. And next 1 plus cos y. 1 plus cos y. I've taken cos 2x, second formula. Because cos 2x has totally 4 formulas, and that I am taking second one. The purpose of I am taking second one is positive here. 1 plus cos y is second formula. 2 cos square x minus 1. This is the second formula. In this student, I will shift this minus 1 to other side. I will get 1 plus cos 2x, and that is equals to 2 cos square x. So in this formula, again, wherever there is an angle, there I divided by 2. Multiple angles are converted to. Okay, students, now let us go to the next problem. Find dy by dx if x cube plus x square y plus x into y square plus y cube is equals to 81. Student, here we have 4 terms, and in this 4 terms, second and third terms are having multiplied functions. 2 functions are multiplied, independent and dependent. So in these two cases, we must use product rule. Solution. Given x cube plus x square y plus xy square plus y cube is equals to 81. Again, we must differentiate y with respect to x. Differentiate y with respect to x. Direct differentiation here. Derivative of x cube is 3x square plus u into v rule here, because as I said, 2 functions are multiplied. So that says that first function as it is, derivative of second is dy by dx plus second as it is, derivative of first term. Derivative of that is x square is 2x plus, now comes to this one. This is u and this is v. First is x, second is y square. So its derivative is, first function as it is, derivative of y square is 2y into dy by dx plus, I write it there, plus second as it is, derivative of first is x, its derivative is 1, plus derivative of y cube is 3 y square. Since here y is dependent variable, we must differentiate this y with respect to x. So it becomes dy by dx. That should be equals to 0. Because 81 is a constant, derivative is 0. So finally what I am getting, I have 3 dy by dx terms. Then other terms I will shift it to other side. I have x square dy by dx plus 2xy dy by dx plus 3y square dy by dx. I'll write it here. That is equals to, this term I am shifting to my right hand side, so it changes its sign, 3x square. This I am shifting to my right hand side, so it changes its sign and becomes 2xy. And this I am shifting to my right hand side, this becomes y square. Now student, in this left hand side, I can easily take dy by dx common. I am taking dy by dx common. Then what is left out here? X square plus 2xy plus 3y square. This is equals to, minus I take common in this, get 3x square plus 2xy plus y square. Finally, my dy by dx is equals to minus 3x square plus 2xy plus y square divided by x square plus 2xy plus 3y square. Now student, this is about implicit functions problems. I hope you people understood the concepts of implicit functions and how to find the derivative if the function is implicit function. Now student, let us move to the next topic, that is finding the derivative of an inverse trigonometric functions. Inverse trigonometric functions. Student, here domain for x or to the function is very, very important. That is, the restriction for x is very important here. For each and every problem, it will be different according to the problem. So that we should check very carefully before we differentiate. Then after that, the second important thing in inverse trigonometric function derivative is method of substitution we are applying here. Therefore, every problem we will apply the method of substitution. This method of substitution we already studied in inverse trigonometric functions chapter. Same concept will apply here. After final answer, we will differentiate the function. So in method of substitution, there are 3 cases. Let us discuss those things first. The first case, in our function, in our inverse trigonometric function, if we have 1 plus x square, in place of 1 it can be a square also, but I will call it as constant and x square. If we have like this constant plus x square, in this particular problem, the value of x should be tan theta. We should substitute. As I said, derivative of inverse trigonometric function is possible with the method of substitution. And in method of substitution, if this situation comes, then x value is substituted as tan theta. If there is a here, then we take x as a tan theta. That is, if it is a square plus x square, then we take x as a tan theta. With the help of this, if you want, we can find the value of tan theta or theta. This is first case. That is, if we want, we can write it as like this: tan theta is x by a. Finally, my theta is equals to tan inverse x by a. Second case. If I have 1 minus x square in the denominator or anywhere in the function, then we can consider x is equals to sin theta. X is equals to sin theta. Then my theta will be sin inverse x. Or if suppose if it is like this, a square minus x square, that means constant is positive, x square is negative. If this situation comes, we can consider x as, or we can substitute x as a sin theta. So our sin theta is equals to x by a. This theta is equal to sin inverse x by a. Third case is x square minus 1. In this case, x square is positive and the constant is negative. Here we should take the value of x as secant theta. X we should substitute as secant theta. That implies theta is equals to secant inverse x. Secant inverse of x. If suppose x square minus a square, that gives x is equals to a secant theta. Then finally, secant theta can be written as x by a. That implies theta is equals to secant inverse x by a. And these are the three cases we will follow to find the derivative of inverse trigonometric functions. And since it's very easy, because here you have taken only ratios of trigonometric functions. You have not taken any co-ratio here, taken ratios. And student, the moment we substitute x is equals to tan, sin or secant, make sure that we are getting a direct formula. After substitution of this thing, if you are not getting a direct formula, then somewhere you are wrong. We should check one more time. But usually we will get the formula after we substitute x is equal to tan. Either we will get the formula in terms of tan, or we will get the formula in terms of sin, or in terms of cos, definitely. But make sure that the moment we substitute x is equal to tan in a given function, then definitely we will get one particular formula for all those terms. all those equations. Okay, students, now let us go to the problems. Its first problem is find dy by dx if y is equals to tan inverse dx minus x cube divided by 1 minus 3x square if minus 1 by root 3 less than x less than 1 by root 3. So here the function is y is equal to tan inverse 3x minus x cube divided by 1 minus 3x square. The purpose of substituting x is equals to any ratio is to remove this inverse trigonometric function. The moment we remove this inverse trigonometric function, we can directly differentiate this. Here, the function is y is equals to tan inverse 3x minus x cube divided by 1 minus 3x square. So student, whatever the value we are giving to x here, with that we should get a formula related to tan. Because our intention here is to remove this inverse trigonometric functions. The moment we remove this inverse trigonometric function, then only it's possible to differentiate. But before that, we cannot differentiate. So to get this complete in terms of tan directly or part, part I don't think there is a formula here. So, but tan is exist. With that, I will put x as tan theta here. Given y is equals to tan inverse 3x minus x cube divided by 1 minus 3x square. I will put x as tan theta because constant here is 1. Put x is equals to tan theta. With this, what is my theta? My theta is tan inverse x. So y is equals to tan inverse 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. So this complete inside the bracket, whatever I've written, it is a form of tan 3 theta. So y is equals to tan inverse sine tan 3 theta. And this is the exact form. This is the exact form of tan 3 theta. Now tan inverse and tan gets cancelled. So we get y is equals to 3 theta. Because function and inverse function both comes together and both will get cancelled. I've seen a property called tan inverse x into inverse of x into tan x is equals to x. So what is theta now? That gives 3 is equals to our theta is tan inverse x. So different, now I can differentiate. With this side inverse trigonometric I remove. Now it's easy to differentiate. Differentiate y with respect to x. So what is the derivative of y? Dy by dx is equals to, this 3 is a coefficient as it is. Derivative of tan inverse x. 1 divided by 1 plus x square Derivative of tan inverse x is 1 by 1 plus x square. Finally, we can write this as 3 divided by 1 plus x square. This is the final answer. Okay, students, now let us go to the next problem. If y is equals to cos inverse 1 minus x square divided by 1 plus x square, if x is lies between 0 to 1, find dy by dx. Find dy by dx. Student, here cos inverse of 1 minus x square divided by 1 plus x square. I will put again x as tan here. Y is equals to cos inverse 1 minus x square divided by 1 plus x square, 0 less than x less than 1. So here, I'll put x is equals to tan, because we know that 1 minus tan square divided by 1 plus tan square as a formula, and that is a formula of cos 2 theta. That is the fourth formula of cos 2 theta. So I'll put x is equals to tan theta here, which implies my theta is equals to tan inverse x. If I put x is equals to sine here, I don't have any formula for 1 minus sine square divided by 1 plus sine square. Won't get any formula. So as I said in the beginning itself, the moment you are substituting x is equals to any trigonometric ratio, make sure that you are getting a direct formula. If you are getting a direct formula, then your substitution is correct. Then what happened to the function now? It becomes y is equals to cos inverse 1 minus tan square theta divided by 1 plus tan square theta. To cancel this cos inverse, I need one cos terms inside the bracket. So with this, I will get, this is cos inverse, I'm getting cos 2 theta. Inside the bracket, whatever is it, that can be written as cos 2 theta. It is the fourth form of cos 2 theta. So again, inverse and function comes together, both get cancelled here. So finally, I will get y is equals to 2 theta. That is, y is equals to, my theta is tan inverse x. So differentiate y with respect to x. Dy by dx is equals to as it is, derivative of tan inverse is 1 plus x square. Finally, this becomes 2 divided by 1 plus x square. Okay, students, now let us go to the next problem. It's if y is equals to sine inverse 1 minus x square divided by 1 plus x square, and 0 less than x less than 1. Find dy by dx. Find dy by dx. Solution. Given sin inverse 1 minus x squared divided by 1 plus x squared. Student, here I will put again x as tan only, because the only reason is I have the formula. If I substitute x is equal to tan, if I substitute x is equal to any other trigonometric function, don't have any formula. Whatever it is, whether I have sin inverse or cos inverse, that I will see later. The exactly same formula if you compare to the previous problem. The only difference is this. There it was cos inverse, now it is sin inverse. But in both the case, I will put x as tan only. Put x is equals to tan theta. This value of theta is tan inverse x. We get y is equals to sin inverse 1 minus tan square theta divided by 1 plus tan square theta. So we get y is equals to sin inverse cos 2 theta. Question here, this is the formula of cos 2 theta. What cos theta? But I cannot cancel this sin inverse law. How can I cancel this sin inverse? The only way is I should convert this to sin. And in first piece we studied that cos theta can be written as sin pi by 2 minus theta. Now this is in first quadrant, all are positive. First quadrant can be represented as 90 minus theta. So our cos theta is sin 90 minus theta. And thus becomes sin inverse sin pi by 2 minus 2 theta. Now I can cancel sin inverse and sin. So what do I get? Y is equals to pi by 2 minus 2 theta. So here theta value is tan inverse x. Now let me differentiate this. Differentiate y with respect to x. What I will get? dy by dx is equals to pi by 2 is a constant, so its derivative is 0 minus 2. Derivative of tan inverse x is 1 divided by 1 plus x square. And final answer is minus 2 divided by 1 plus x square. Okay, students, now let us go to the next problem. If y is equals to cos inverse 2x divided by 1 plus x square, where x is from minus 1 to 1, find dy by dx. Now, student, in this problem is y is equals to cos inverse 2x divided by 1 plus x square. Then in this problem, I have 1 plus x square. When I have 1 plus x square, according to the three cases which we discussed before we start the problems, is x I can consider as tan. I can substitute the value of x as tan theta. So with that, let me directly substitute. Put x is equals to tan theta here. this my theta is tan inverse x. Will I get a direct formula if I substitute x is tan theta? Yes, I will get a direct formula. So let us see what is that formula. Y is equals to cos inverse 2 tan theta divided by 1 plus tan square theta. Now see here, y is equals to cos inverse. Then this is the direct formula of sin 2 theta. And this is the second formula of sin 2 theta. In our first PUC trigonometry, we derived multiple angle formulas. There we studied that sin 2 theta has two formulas. First is 2 sin theta into cos theta, and the second formula of sin 2 theta is 2 tan theta divided by 1 plus tan square theta. So this is sin 2 theta. So this is the direct formula of sin 2 theta. Now, as we discussed in the previous problem, that we should cancel this inverse function, but we have sine here. So somehow we should convert this sine to cos. For that, again we will use allied angles, and in first quadrant, that is sin theta can be written as cos 90 minus theta. First quadrant. So y is equals to cos inverse of cos pi by 2 minus 2 theta is angle here. So cos inverse and cos gets cancelled. So y is equals to pi by 2 minus 2 theta. So here our theta is tan inverse x. So if I differentiate this, differentiate y with respect to x, then I will get dy by dx is equals to, it is exactly similar to the last problem. Derivative of pi by 2 is 0 because it is a constant, minus 2 into derivative of tan inverse x is, its derivative is 1 divided by 1 plus x square. Finally, it is minus 2 divided by 1 plus x square. Let us go to the next problem. If y is equals to sine inverse 2x into root of 1 minus x square, where the value of x is between minus 1 by root 2 to 1 by root 2. Find dy by dx. Question. Solution. Given y is equals to sine inverse 2x into root of 1 minus x square. Student, as we discussed in the three cases, whenever we will get 1 minus x square, whether it has root or it doesn't have root, no need to worry about that. Minus x. In this situation, I said that we should substitute x as sine theta. Put x is equals to sine theta, because their constant is positive, x square is negative. So in that situation, always we should substitute x as sine theta. So with this, our theta value is sine inverse x. So we get y is equals to sine inverse 2 sine theta into root of 1 minus sin square theta. This becomes sin inverse 2 sin theta. Since 1 minus sin square theta, according to first identity, 1 minus sin square theta can be written as cos square theta. Now here square and root gets cancelled. So y is equals to sin inverse 2 sin theta into cos theta. 2 sin theta into cos theta is the first formula of cos 2 theta. So this is the first formula of sin 2 theta. Sorry, not cos 2 theta. 2 sin theta into cos theta is the first formula of sin 2 theta. So this is sin inverse of sin 2 theta. Now sin inverse and sin both exist here, so both will get cancelled. We will get y is equals to 2 theta. What is my theta? Here our theta is sin inverse x. Differentiate y with respect to x. So we will get dy by dx is equals to 2 into derivative of sin inverse x is 1 divided by root of 1 minus x square. Final answer is 2 divided by root of 1 minus x square. Now let us go to the next problem. If y is equals to secant inverse 1 divided by 2x square minus 1, where the value of x is between 0 and 1 by root 2. Find dy by dx. Understand here? It has given secant inverse. Y is equal to secant inverse 1 divided by 2x square minus 1. Student here, secant inverse. I should cancel secant inverse. My target is to cancel this secant inverse from this function. Now to cancel this, I will put x is equals to cos here. Because if I put x is equals to sin, tan, or any other function apart from cos, I won't get any formula. But the moment I put x is equal to cos here, I get a direct formula. Let us see how it is possible. X is equals to cos theta here. So this I did explain in the 3 cases. The beginning of the inverse trigonometric problem, I explained the 3 cases. There I didn't explain this case. Here this is the only case where we are taking 4 ratios also. 4 ratios of trigonometric functions we are taking. And in this particular case, if I put x is equal to cos theta, then my theta is cos inverse x. My function will be y is equal to secant inverse 1 divided by 2 cos square theta minus 1. This I got the second formula of cos 2 theta. The denominator. This is the second formula of cos 2 theta. Cos 2 theta is equals to 2 cos square theta minus 1. Cos 2 theta has 4 formulas, but this one is the second one. So y is equals to secant inverse 1 divided by cos 2 theta. So student, in our first piece we studied the reciprocal of cos is secant. 1 by cos can be written as secant theta. Y is equals to secant inverse of secant 2 theta. The 1 by cos is secant, so this secant 2 theta. Now secant inverse and secant gets cancelled. As I said, inverse function and the direct function comes, both gets cancelled. So this becomes 2 theta. So my y will be 2 into, here my theta is cos inverse x. Cos inverse x. Differentiate y with respect to x. If I am differentiating this with respect to x, I will get dy by dx is equals to 2 into derivative of cos inverse x is minus 1 divided by root of 1 minus x square. This is equals to minus 2 divided by 1 minus x square. Then this is the final answer. Student, I hope you understood this inverse trigonometric functions problems as well as implicit function problems. Student, if you have any doubt in today's topics, you can put your doubt in comment box. And student, if you are new to our channel, don't forget to subscribe. And to help other students, keep sharing our videos so others can be benefited with this. Thank you, student.